Alright, we have this function, and on the test it said use logarithmic differentiation. Many of you use the quotient rule, and boy did you get yourself into trouble and had a lot of work. But it did say use logarithmic differentiation. So basically what that means is to take logs of both sides. And I'm hoping that you realize why, because it's way easier than going through all of this madness to do a quotient, a chain, a product rule. So if I do that, I'm going to have ln of y on this side. The first thing I see, and I'll do this in lots of steps, is that, but some of you probably could have done this in one step, but I'm going to separate first my quotient into subtraction. So that's my first step. The next step is I'm going to separate the product into a sum. And then I can write this as the 1/2 power. So using the power rule, I'll bring the 1/2 down, and that gives me this. So ultimately what you're doing when you're doing logarithmic differentiation is you're putting everything in terms of logs with just one term inside here, because that way it makes it very quick and easy. Okay, let's take derivatives. The derivative of ln of y, 1 over y, but notice this is with respect to theta. The derivative of ln of theta, 1 over theta. The derivative of ln of sine, 1 over, hello, I'm thinking ahead of myself, 1 over sine times the derivative of the inside, which would be cosine, and then minus 1/2, the derivative of ln of secant would be 1 over secant, and I'm going to need some room here, and then the derivative of the inside, which would be secant tangent. Get everything close there. So basically what I did is I took the derivative of each piece. These pieces here, the last two, just had some chain rule. So the derivative of ln of anything is 1 over the anything times the derivative of the anything. The derivative of ln of anything, 1 over the anything times the derivative of the anything. And pretty much from here, I mean, I could, do some playing around with stuff, but I'm pretty much done. Is I could cancel that. I'm solving for dy d theta, so when you move the, let me get some room here, when you move the y to the other side, you're multiplying it on both sides. So that's my y. Well, my y was the original problem, all over that piece. And then on the test I said don't worry about simplifying that, just worry about simplifying this side. Well, this next term here is going to end up being cosine over sine, which is going to be cotangent. And then I have left here minus tangent over, that's a very ugly 2, but that's a 2. So that's that 2 right there. All right, and again, I mean, there were so many of you that did this with the quotient rule, but it specifically said use logarithmic differentiation, and this is the whole reason why. It makes it way easier. Because like I said, many of you probably could have written this line as your first step. You could have seen to separate the quotient into subtraction, separate the product into addition, and then brought down the 1/2.